Hello everyone, welcome for this lecture. Today we are going to discuss series type of faults in unsymmetrical faults. Okay, let's see what and all we have studied and what we are going to study. Till now, we have studied the unsymmetrical faults. Under that, as we know, unsymmetrical faults there are of two main types. Okay, types are of only mainly two. One is shunt faults, another one is series faults. In shunt faults, single line to ground fault, again there are three types. Okay, first one is single line to ground fault, double line to ground fault, and line to line faults. Okay, about these three faults we have studied. It's a sequence network. Each sequence networks we have studied. Okay, and today what we are going to study is a series type. As we have said, there are two types. First one is a shunt, another one is a series. So shunt we have completed. Let's see the series type, the series faults. Okay, in a series type faults there are again two types, one conductor open and two conductor open. Okay, this also happens in a power system. Okay, let's see that one by one today. Let's see the introduction of this. Till now, as we have discussed the various shunt type of faults that occur in a power system, in this power system, unsymmetrical faults, in that unsymmetric faults, the open conductor types also takes place. Okay, so that we need to determine the sequence components of that current and voltage across the broken ends of the conductor. Okay, let's find out this. Let's consider circuit of open conductor. It is overall open conductor faults. Okay, let's say this is a B C conductors. Okay, so suppose if a fault occurs at this point. Okay, so end of this A conductor is mentioned as A dash, B dash, C dash. Okay, ends of those conductors are represented as at a fault. Okay, A dash, B dash, and C dash. Okay, and this fault is represented as F dash. Okay, so now we need to calculate its symmetrical components of voltages and symmetrical components of currents. Let's see how we are going to represent these symmetrical components of voltages. Okay, so we are going to represent VA dash of 0. Okay, which 0 indicates that 0 sequence of that conductor. Okay, voltage. Similarly, VA dash of 1 is a positive voltage sequence. Okay, and similarly VA dash is 2. Okay, these three are of 0, positive and negative sequence components respectively. Okay, similarly current of this can be represented as IA0, IA1, IA2. As we know, it is a 0 sequence, positive sequence, and negative sequence current. Okay, let's see this sequence networks is indicated as like this. Okay, this is a positive sequence network, negative sequence network, and it is a 0 sequence network. Okay, it is means a fault at that point is ends of that fault is considered as FF dash. Okay, and then voltage across this is VA dash of 1, this is VA dash of 2, VA dash of 0 is nothing but your positive, negative sequence, and 0 sequence. Okay, so as we know, there are of two types of open series type of faults. Okay, these are of classified as one conductor open fault and two conductor open fault. Let's see one by one of this. Let's take a first one, open conductor one conductor open fault. One conductor open fault, as the name itself indicates, that among three conductors one has to be open. Here we are going to assume that a conductor is opened. Okay, here we have considered a conductor as open conductor. You can consider B or C. We have considered A now. Okay, this is, as we see, this is your A conductor, so current flowing through this will be IA. B conductor, so current through this will be IB, and this is a IC. Okay, assume that fault is occurred at here. So end points of this one is mentioned as A dash, B dash, and CC dash. Okay, observe these are not opened. Okay, these are kept closed. So only first first conductor is open. So what we can write a terminal conditions for this. Okay, what are the terminal condition for this circuit is, observe IA is open circuit, right? Conductors are open, therefore IA will be equal to 0. right? Since this BB dash and CC dash are a short circuit, it means these are not opened, there that you can consider as a short. You can take it as VBB dash is equal to 0 and VCC dash is equal to 0. These are your terminal conditions, or you can say these are boundary conditions as well. Okay, let's call this equation number 1, right? Next, we need to express, as we know here, just observe once. Okay, current is 0 in this first conductor, but voltage is present, right? VAA dash is voltage is present. So this voltage we need to express in terms of symmetrical components. Okay, let's express that. So it is V dash of 0, sorry, V dash of 0 1 2, 0 sequence, positive sequence and negative sequence will be equal to, in terms of your voltages, okay, phase voltages. So that this formula we are well known, only thing is notation, means representation is different. As per the requirement we have to do it. Okay, so that is equal to 1/3 of this matrix 1 1 1 1 a square 1 a square a into VAA dash, VBB dash and VCC dash. Okay, let's take what is the 0 sequence, positive sequence and negative sequence voltage of that. Okay, therefore VAA dash will be equal to 1/3 of, means just expanding of this one. This one will be equal to this into this, that is VAB dash plus BB dash plus CC dash. Okay, so but as we know VBB dash and VCC dash is equal to 0, what we can do is these two values are equal to 0. Therefore VB dash of 0 sequence component will be equal to 1/3 of VAA dash. Okay, and next similarly we can calculate for a positive, that is represented as VAA dash of 1, which is equal to the same, that is now we have to do with this multiplication. This is V equal to 1/3 into this into this. Okay, observe 1/3 of 1 VAA dash, okay, VAA dash plus A into VBB dash plus A square into VCC dash. As we know these two are equal to 0, again this is also equal to same thing, that is 1/3 of VAA dash. Right, similarly for negative sequence, write the expand this matrix, again substitute the values of these two equal to 0 0, again we get CC dash is equal to 1/3 of VAA dash. Let's call observe, therefore observe these three, like 0 positive and negative sequence, that is VAA dash of 0, of positive, for negative will be all are equal to 1/3 of VAA dash. Let's call this equation number 2. Okay, and then next from equation number 1, that is the boundary condition, we said that IA equal to 0 since it was open. Okay, open conductor, therefore what we can write is IA naught plus IA1 plus IA2 will be equal to 0. Okay, so this is equal to 0. Observe your equation number 2 and 3. Okay, equation number 2, yes, this is equation number 2. Okay, all voltages are equal. Okay, and summation of current will be equal to 0. What is the condition of this? Means it represents what? All voltages are equal, means is this a parallel circuit? Yes, therefore, and summation of currents is equal to 0. It indicates that this sequence network consists of parallel combination. Okay, therefore we can represent all sequences like positive sequence, negative sequence and 0 sequences in parallel connection. Okay, this is IA1 flows, IA2 flows and IA0 flows, so all these are in parallel. Okay, this is the sequence network of one conductor open circuit. Okay, so since we need to calculate voltages and current flowing through that as 0, we have calculated a voltage of that, and all were equal to 1/3 of VAA dash. Okay, let's next see next type, that is two conductor open fault. Okay, here let us assume that the two conductors B and C get open at the points of FF dash as shown in the below. Okay, remember fault is occurring here. Okay, so we have assumed that B conductor and C conductors are open. You can take, as we have said earlier also, you can consider any two conductors open. For our convenient, we have taken here B and C conductors are open. A conductor is closed, means it is not open. Okay, so since it is A conductor, B conductor, C conductor, so current flowing through that is IA, IB and IC. Remember, let's write the terminal conditions for this. Okay, since IB is open, so therefore current flowing through that is equal to 0, right? And then current conductor C is also open, therefore these are also terminal conditions. IC is equal to 0, right? And then what about this is a short circuit, like, right? It is not open, so at that fault condition it is VAA dash will be also equal to 0, right? This we can take. These are your terminal conditions. I hope you have got how to write these terminal conditions or boundary conditions, right? Let's see all those things we have written here. Okay, so IB equal to 0, IC equal to 0, and VAA dash is equal to 0. Let's call this equation number 1. As we know, we are supposed to see VAA dash is equal to 0, but there should be, like, old current. Okay, current flowing through that current we need to calculate. So that current has to be expressed in terms of symmetrical components. Therefore IA naught, IA1, IA2 will be equal to each conductor, okay, each conductor current, that is 1 A square, 1 A square A into 1/3, okay, into IA, IB, IC. As we know, B and C's values are of 0. Okay, therefore expand the same equation. Okay, IA not equal to this into this, right? So if you express, put IB and IC value equal to 0, you get IA not equal to 1/3 of IA. Similarly, you can calculate IA1 is nothing but your this row into this column. Okay, as you know, IB and IC values are of 0, so again it will be IA1 equal to 1/3 of IA. Okay, therefore similarly you can calculate your IA2 also, negative sequence current, that is also comes 1/3 of IA. Here if you have observed, your 0, positive and negative sequence currents all are equal. Okay, all are equal, therefore we can write IA not equal to IA1 equal to IA2 equal to 1/3 of IA. Current is same in the circuit. Okay, I hope you are getting what kind of a sequence network we may get in this. Okay, and from the equation 1, VAA dash, okay, VAA dash is equal to 0 means addition of sequence components of that particular voltage will be equal to 0. See, 0 sequence voltage, positive sequence voltage, and negative sequence of this voltage will be equal to 0. So what is these two conditions represent? Current are same and voltage, addition of all this voltage will be equal to 0. This indicates a series type, okay, circuit. So therefore our sequence network will be of a series type. Let's consider this is a positive sequence, negative sequence, and a 0 sequence. So all three should be connected in series. So this has to be connected to this point, this end has to be connected to this point, and this end connected to this point. Therefore this is the sequence network of two conductor open fault. Okay, so we'll see the numericals on the further classes. Thank you.